In this video we're going to take a look at the Brainy Cipher challenge on HackTheBox. It's an easy crypto challenge, and the description says Brainy likes playing around with esoteric programming. He also likes maths and therefore encrypted his very secure password with a popular encryption algorithm. Claiming that his password cannot be retrieved now, he has sent ciphertext to some of his friends. Can you prove to Brainy that his password can actually be recovered? So I last solved this, or I solved this over 3 years ago. So I can't remember exactly what it entails, but I have a good idea based on the description and the name what we're gonna need to do. I'll not spoil it just yet. Let's take a copy of the files called brainy.txt and let's do some basic checks. So if we just print the file out first of all, see that we have a file which consists of dashes, dots, pluses, and square and angular brackets. So if you haven't seen this before, this is quite instantly recognizable as a language called brainfuck. I'm going to go to, let's see if CyberChef has this. I don't think it does. I'm going to go to CyberChef and type brain. No. Let's go to decode.fr and search brain. You can see here, first thing that comes up, brainfuck. Let's have a look at it. You can see here, it's brainfuck code to interpret. If we execute that, it comes out with decode. We have a decode, brainfuck encoder. Okay, so we can put in here, hi crypto, and encrypt that. We get out this message. Oh god. We get out this message, we can paste that in here and hit execute, and it decrypts it as hi crypto, and tells us a little bit about it. So let's have a look here. How to decrypt, how to recognize. The message is composed of 8 characters, so they're angular brackets plus dash dot comma and the square brackets. There are some different variants as well, so that be worth bearing in mind. If you see something that maybe looks like brainfuck but isn't decoding properly, then it might be a variant. How to encrypt. It's not a proper encryption system, but rather a programming language that has been obfuscated. Encoding consists in writing machine code that returns text as an output. And here's the operations. So the angular brackets, or greater than, less than signs, are increment and decrement the pointer. The plus is increment byte in the memory cell where the pointer is located. The dash is the reverse of that, to decrement it. Dot is to send the value of the pointed byte as output, treat it as an ASCII value, and then the comma is to insert an input byte. The square brackets indicate if conditions, so whether to jump or not jump. So we've looked into what brainfuck is and how to encrypt some text. Let's try and decode the text which we have here and see what we get. Paste that in, execute, and okay, we get out a P and a Q value. Let's copy this. Let's go to Sublime, paste this in. So it looks like we have some RSA values. Actually, let's format this properly as well. I'm not too sure how to do that in Sublime. I'm going to go to JSON formatter. I could just open it in VS Code as well, would auto format it, but let's just throw it in here. Obviously not putting in any sensitive data that we wouldn't want the site owners to have access to. And here we have our P, Q, DP, DQ, and our ciphertext. So it looks like an RSA algorithm. We can try and decrypt this ciphertext now. Let's close some of these windows down. So let's see what options we have for decrypting this. We could, if we have a look at CyberChef here and go to our public key section, we have some RSA options like RSA decrypt, but it'll take an actual private key, which we don't have access to. We have access to the values which we use to generate the private key, and then we have the ciphertext as well. So let's clear the recipe. We have the generate RSA key pair as well here, but this is going to generate a key. We already essentially have the values needed for the key. If we go to JSON, in fact, you'll see here we should have something similar to this, although yeah, not in the same format. But let's you see here P and Q. We do have them here, it's just in a different format. So let's see what else we could do. We could use a tool called CryptTool, which allows you to plug in these values. I have this over on the Windows system, and it's pretty good, especially for learning. We use this in our crypto module in Masters in Cybersecurity, and it's quite good going through step by step and seeing what's going on. In this case, we'll not bother with that. Let's try and look here for RSA in Decode. We have an RSA Cipher here, and it says currently the RSA decryption is unavailable. However, the following decode tools can be used to decrypt RSA semi-manually. What I'm going to do is I'm going to have a look at the CTF tools list. Oh no, wait, this is Pwn tools, not that. CTF tools. So I've put this link in the description. We've used it in a couple of the challenges here. Let's go down to the crypto section, and we used the RSA CTF tool in the previous one, so we could use that. We could also use the RSATool because it says generate a private key with knowledge of P and Q, and we have P and Q, and we have our ciphertext. Why don't we try to do the RSATool, since we've already done we've already used the RSA CTF tool in a previous exercise, so let's try something new. I'll take a copy of this and place it in the description as well. Let's see what we need to do. So if we set this up, we can run Python RSATool -fpem for the type, and then the output file, and then we give it n, and we give it, in this case, d, or we can supply 2 primes. So we don't have d, we have p and q. We have d, dp, and dq, which are the modular inverse of P and Q. So let's clone this repo. Do git clone to RSATool. Let's go into the RSATool. Let's activate our Python virtual environment. We'll do PyEnv3 probably. Let's see. It was last updated 9 years ago. Python 2.6. So let's do PyEnv2. And do we have a requirements thing here? No. Okay, so we'll just do, I'm going to do pip install that, and then what was the other thing? Pip install gmpy. Try to install those two. We get an error trying to install this, which is quite typical. Let's try and run a, let's try and Google this error and just see if there's a quick fix. Is it trying to go to this as a website? It looks like it is. Please Google this. Don't. Let's have a look at this error. 2014. Okay. apt-get Python dev. Let's go. Alright, installed that. Let's try and install gmpy again. And it installed successfully. So let's try out this tool. Let's run Python RSATool. Oh, there was a setup there. Oh, it would have just installed our requirements and stuff. Okay, well, we did it manually anyway. Let's see. RSATool, it needs either P and Q or N and D to be specified. So we're going to give Python RSATool. We're going to give -p. Oh, not equals P. -p. Where's our P? It's right here. Paste that in. We'll give it a -q, and we'll give it the Q. And is there anything else? Format, let's do -F. Okay, it already has default as PEM. -O for file name, so we'll do -O and then child.pem. Alright, so you can see that it's generated N, it's got its encryption, it's got its decryption key, it's got P and Q here. Were the numbers too large here? Okay, didn't create the file either. What other outputs could we give it? Maybe if you try DER output just to see if it does it without the error. Let's do -F DER dash. Oh no. Does it? We can't give it ciphertext, can we? No. Okay. I'm gonna do dash output test.der. No. Alright, we get the same error. It might be to do with maybe the lengths of these, of the P and the Q value. I'm not too sure. Okay. It takes 2 primes, we give it P and Q, or it can take N and D. We now have N and D, so why don't we try this again, and we'll do -N. Okay, we'll do it again. We'll do Python RSATool, open a new Sublime file, and just go and get rid of these annoying spaces and new lines. Do -N, put that in, and then we'll do -D, and oh, that was our -D. So that was -D. Let's do -N. Let's paste it here. Oh god. Copy that. Oh, what? We copied the D again. That's my bad. Oh my god. Okay. If you didn't laugh, you'd cry, you know? Okay, let's run that. Invalid integer value for -N. It's the N that you gave me. Alright, this tool is useless. I'm gonna go to the, let's grab the RsaCTFTool here. I already have it set up, but I'm gonna set it up locally again just because. RsaCTFTool. Was there anything else here worth looking at? No. This is an attack tool, shouldn't really be needed at all. So for our usage here, you can see that we can specify a variety of things. We can specify N and P and Q, things that we have available to us. So let's git clone RsaCTFTool. If anybody got this working with the RSATool, by the way, oh, let me go back a directory. If anybody got this working with the RSATool, let me know what I did wrong, because I'm surprised that didn't work for us. Let's go cd RsaCTFTool. Let's try this out. So Python RsaCTFTool. Let's see what options we've got here. I'm gonna deactivate my Python environment here. I'm gonna activate the Python 3. I'm gonna do Python RsaCTFTool. No module named requests. It's always something. No module named crypto. I definitely. Okay. PyCrypto. Pip install PyCrypto. Feels like I have to do this all the time. Alright. Let's try run that. Pip install gmpy2. And there's that installed. Let's try it again. And it's working. Awesome. So if we run Python RsaCTFTool, we can provide it. We can give it some things to uncipher here. So we could give it the ciphertext. Let's first of all specify our p value. I'm going to close this. This was useless. Let's give it the p. Let's give it the q. What else can we give it? Password, okay, it gives it, suggests the attacks. Alright, we'll say uncipher then, uncipher. And hopefully the format of this isn't an issue. Try to run that. If len args public key greater than 1. Let me try and take out the uncipher bit. And we'll set private and just see if it can return a private key. No, it's the same, okay. Maybe it needs, maybe it's not able to do it without E. It's saying here if length args public key, which is something that we don't have. Let's have a look online and see if there are any scripts then, seeing as the two tools, RSATool and RsaCTFTool, seem to be causing us some problems, or because I don't know how to use them, I don't know, one or the other. Let's search Python RSA, and then what parameters do we want to plug into our Python script? It's these ones here, so P, Q, DP, DQ. So we'll search P, Q, DP, DQ, and C. Try and grab a script to do this for us. Go on the first link here, picoctf weird RSA, and they recovered some data labeled as RSA, but what in the world are DP and DQ? So they have the same values here that we have, and they look into that and see that DP and DQ are used in the Chinese remainder algorithm, which is used in a lot of popular crypto libraries, and they do some searching and find the Python code to calculate the modular inverse, which is the key kind of mathematical problem in RSA, the Euclidean algorithm, or extended Euclidean algorithm. Maybe at some point after I've gone through these HackTheBox retired challenges, I might do some crypto series and go through different algorithms. I actually coded RSA, DES, AES and things like that from scratch back in my undergrad days, but I can't, I can remember so little of it. I remember particularly the likes of the key generation and stuff on AES, taking a while for me to get my head around. But anyway, that's a detour. Let's see what we need to do here. We need to plug in our values, and then we're going to use this extended Euclidean algorithm to get the modular, to calculate the modular inverse, and then here we're getting modular inverse. We do M1, M2, and then RM at the end here is going to be our plain text. The last thing that they do is convert it back into a hexadecimal value and then convert to ASCII characters. Okay, so let's put together a Python script to do this. Let's do codium custom.py. I'm going to just throw this object in here. This is our params, and let's see what else we had here. We needed to get the modular inverse. Oh, let's grab this because it doesn't have the angular brackets. Come on. Alright, so there's some of the functions we're going to need. Did they have any imports here? I don't see any at the moment. And then we are calculating. Let's copy all this. And we'll do Control F, and we'll replace these with nothing. Oh. Okay, there we go. And the only thing here is we have the way we've set up our params here. Just trying to think, is it going to be easier for me to go through, and it's probably going to be easier just to let's take this out of a dictionary. Get rid of these commas at the end. And then we don't have any other quotes in here, so let's just replace all quotes with nothing. And then I don't know how to do inside selection here. Preserve case, replace all, find in selection. Okay, so in the selection we want to replace colons with equals, replace all, and hopefully that will allow us to print M. Let's clear the screen, do Python custom, and right enough, we've printed M. What was the last stage they suggested to do? Turn it back into hexadecimal and calculate the ASCII values. So presumably we can just go to CyberChef and we could put this in. We could say 2 hex and then to ASCII. Do we have 2 text? ASCII encode text okay. There's no delimiter there. Oh, this was our okay, sorry. So our input was, let me turn that off. Does it need to be decode text? No. Alright, that's weird. I don't know. I'm going to grab this. I'm going to go to ASCII to hex. Paste in our hex. Oh, okay. That didn't convert to... Alright. This is weird. Let's... we'll grab our decimal value here. We'll convert it to hex. Huh? Weird. Alright, let's just do it in here. I don't understand what's going on here. Alright, we'll just do print M, and can we say decode hex? Int object has no method to decode. Convert it to a string and then decode as hex. Oh, string has no object decode. Let's use a print format, so we can say let's print and we want to print it, pass in M, and then run decode on that. Okay, it printed that out, has no object decode. That's funny. Alright, it gives us the error there, but it does actually work. Maybe it's just because, yeah, okay, it works fine without. Yeah, alright. So we have our hex value. Now we could go and convert this to ASCII, and there we get our string back. I'm not too sure what was going on with CyberChef there with the formatting, or what was going on with the RSATool or the RsaCTFTool. If anybody's got any ideas, if you solved it using one of those tools, let me know, because I'd be interested to find out how you did it. And any questions or comments, leave them down below. Thank you.